A 3-volt battery is connected across a 1200mm long nichrome wire. A current of 60 milliamps flows through the wire. The first thing I'll do is I'll convert the length of the wire into meters. 1200 millimeters, as you know there's 1000 millimeters in each meter, so I need to divide by 1000, which will give me 1.2 meters. Calculate the resistance of the wire. Now, one of the equations we really must learn is the formula relating resistance to voltage and current. So R equals V over I. We have here the voltage of 3 volts and a current of 60 milliamps. So I'll write 60 times 10 to the minus 3 for milli. The answer to that, I'll use the calculator. 3 divided by 60, then I'll use the times 10 to the power of x button, minus 3. And the answer comes out as 50. This is a resistance, so the units are ohms. Always remember to put units against your answers. What voltage is required to drive 0.75 amps through this wire? We'll start off using the same formula, that's R equals V over I, but this time we want to make the voltage V the subject of the formula. To do this, we'll start off by multiplying this side of the formula by I. What we do to one side of the formula, we must do to the other side of the formula, so I'll multiply the other side by I as well. This side of the formula now is divided by I and multiplied by I, so I can cancel those two operations out. That gives me V equals IR. V equals IR. The current is 0.75 amps. And the resistance we've already calculated here is 50 ohms. .75 multiplied by 50. And the answer is 37.5. We're calculating a voltage, so the units that we must put down are V for volts. What current is produced by a PD, potential difference, of 350 millivolts across this wire? Again, we're going to start off by using the same formula, R equals V over I. We rearrange that in the last part of the question to give me that V equals IR. And this time I want to rearrange it to make I the subject. So what I'll do is I'll divide this side of the equation by R. What I do to one side of the equation I must also do to the other. Here we have multiplied by R and divided by R, so those two cancel out. That gives me that I equals V over R. The voltage is 350 millivolts, so I'll write 350 and times 10 to the minus 3 for milli. The resistance I've already calculated in this part is 50 ohms. Now I could use the calculator to do this one, but most of you will be able to spot that 350 divided by 50 is 7. So that gives me 7 times 10 to the minus 3, and the units are amps. It's perfectly satisfactory to leave it in that form, but we could also write it as 7 milliamps. Calculate the resistance for a 2.5 metre length of this wire. Well, there doesn't seem to be enough information here, so I need to return to the beginning of the question to see for the extra information. Here I've got a length of the wire 1.2 metres, and I've already calculated the resistance of that, which is 50 ohms. So what I want to do is to calculate the resistance for 1 metre length of the wire. Now in physics we often say that is the resistance per metre, where the per means divide by. So the resistance I've got here is 50 ohms, and I need to divide by the length for the 50 ohms, which is 1.2 metres. So 50 divided by 1.2, and the answer to that I'll take to be 41.7. So 41.7 ohms for each metre, so per metre, metres to the minus 1. The next thing I want to do is to find out what the resistance will be for 2.5 metres. So the resistance for 2.5 metres is the resistance for 1 metre multiplied by 2.5. Now you'll notice that already on the calculator I've got the answer for the resistance per metre, so I simply need to multiply that by 2.5. And the answer comes out here, and I'll round that to 104. 104, and the units for resistance are ohms.